Here's a challenge. Can you find every force in this 5-bar truss in under 2 minutes? So we've got pins at A and rollers at E, loads coming down at B and D. Let's get into it. Step 1. Global equilibrium. First, we need to draw a free body diagram of the entire truss. Next, we take moments about point A. That's negative 400 times 1 minus 800 times 3 plus EY times 4. Why do we do this? Because we're summing moments, and moments are just the force times the perpendicular distance to the pivot point. The 400 Newton load at B is 1 meter from A, and it causes a clockwise moment, which we take as negative. Same with the 800 Newton load at D. It's 3 meters away, also turning clockwise, but EY is at the far end, 4 meters from A, and it pushes upward. So it creates a counterclockwise moment, which we call positive, and we set all this equal to 0 because that's what equilibrium means, no net moment. Now, since this is a planar truss, we're allowed to write only 3 independent equilibrium equations, sum of forces in X, sum in Y, and sum of moments. That's why we can't have more than 3 unknowns at the start. Otherwise, we'd have too many unknowns and not enough equations. Solving the moment equation gives us EY equals 700 newtons. Then we sum forces vertically. AY plus EY minus 400 minus 800 equals 0. Plug in EY, and AY checks out to be 500 newtons. Now let's zoom in on joint A. This method is called the method of joints. We assume every internal force is in tension. That way, if we get a negative value, we know the member is actually in compression. At joint A, there's no horizontal reaction, so AX equals 0. We've got member AB going upright at 60 degrees and member AC going straight across. From sum of Fx, AX plus T, AC plus T, AB times cosine 60 equals 0. From sum of Fy, AY plus T, AB times sine 60 equals 0. Solving those two equations, we get TAB approximately equals negative 577 Newton, so it's in compression, and TASI approximately 289 Newtons in tension. Now let's repeat the same process at joint B. We've got that 400 Newton load pulling down, and tab coming in at 60 degrees. From sum of Fx, TAB times cosine 6 plus T, BC times cosine 60 plus T, BD equals 0. From sum of Fy, negative TAB times sine 60 minus TBC times sine 60 minus 400 newtons equals 0. Working through it, we get TBC approximately 115 newtons in tension, and TBD approximately negative 346 newtons, compression again. Now let's skip over to joint E. We already know EY is 700 newtons up. Combine that with the geometry of the truss, and you get TDE equals negative 808 newtons, compression TCE equals 404 newtons, tension. Finally, at joint C, all the known forces converge, and there's only one unknown left, TCD. We solve it by summing vertical forces at that node, and it turns out TCD equals negative 115 newtons, compression. That's it. All members' forces solved. Did you get the same answers? If you like this, next up we're breaking down how roof trusses hold up a house. It's the same physics, but applied to real-world structures you see every day.